Hello friends, welcome to Notebook. Today we are going to discuss heat as a part of this lesson video. Heat is a very important chapter, my friends. As human beings, heat is an integral part of our lives, and we need to understand heat as a form of energy and its various aspects in science. In this video, we shall be discussing heat, ways to measure it, and the ways it flows from one medium to another. At the end of it, we shall be discussing effects of temperature rise and drop in the atmosphere. Let's look at two pictures, a hot desert and a polar region. The only difference between the two places is a difference in temperature or presence and absence of heat. Friends, you have seen such differences more regularly on weather channels. Weather channels predict the temperature of a place by a certain degree of Celsius or Fahrenheit. These are scales used to measure the extent of heat in a given region. You may already be well aware, my friends, that temperatures indicates how hot or cold a place is. Higher numbers indicate warmer places. So on the India map, if we see that Chennai is 22 degrees Celsius and Delhi is 16, we would conclude that Chennai is warmer than Delhi as per temperature indications on that day. Even at home, we often say that the soup is hot or the ice cream is cold. So basically we can identify between hot and cold sensations and perhaps say which substance is hotter or colder than the other due to sensations. But how do we arrive at these conclusions? What is the Celsius and the Fahrenheit scale? To interpret heat and its effects, we need to learn about these temperature scales. Till the end of the 18th century, heat was considered to be a form of fluid that flowed from a hot body to a cold body. But later on, with experiments conducted by Count Rumford and James Prescott Joule in the 19th century, heat was described as a form of energy. When coal, wood and petrol are burnt, we see fire and heat energy evolve from fuel energy. Similarly, if stones are rubbed against each other or a saw is used to cut pieces of wood, we see heat energy generate. In this case, frictional energy is converted to heat energy. All these examples and others can easily demonstrate that heat is a form of energy. Once we understand that heat is a form of energy, it is important for us to see how it can be measured. This would help us manage extreme heat conditions. For example, when you see your mom using an immersion heater, temperatures on the heater indicate how hot the heater has become. In case of overheating, if you are not able to control the heat, the vessel on the heater could start to burn. Overheating has many dangerous effects like fire. Overheating can happen in any instrument or vehicle. One popular way to measure heat is with the help of thermometers. Temperature is an expression of heat energy, and thermometers can be used to measure heat present in bodies. Coldness is nothing but absence of heat. This brings us to the point where we need to understand the Fahrenheit or Celsius scale. Temperatures are measured with Celsius and Fahrenheit, just as length is measured in kilometers and liquid in liters. You must remember that our normal body temperature is 37 degrees Celsius, 98.6 degrees Fahrenheit. Although Celsius and Fahrenheit both measure heat, their scales are different. So whenever we get to temperature levels higher than the body temperature, we feel hot. A specific thermometer that measures temperatures in humans in case of fever and others is called the clinical thermometer. A clinical thermometer usually measures in Fahrenheit. This thermometer contains a long, narrow, uniform glass tube with a bulb at the end that contains mercury. The liquid mercury is shiny in color and heats up when exposed to temperature. As mercury heats, it travels upward through the thread to indicate the correct temperature of the body. The minimum and the maximum temperatures in a thermometer is between 94 degrees and 108 degrees Fahrenheit at the maximum range in which body heat can fluctuate. Further, a clinical thermometer shows readings such as 100, 102, 104. So, with gaps of 2 degrees of Fahrenheit, there are about 10 marks. Each mark difference represents about 0.2 degrees Fahrenheit. So, if the mercury reading is 3 marks above 102 degrees, the actual scale reading would be 3 times 0.2 degrees equal to 0.6. The final reading is 102 plus 0.6 is equal to 102.6 Fahrenheit. A famous question in your exam could be, why does the clinical thermometer measure temperatures between 94 and 108 degrees only? Well, the point is the clinical thermometer is designed to measure the temperature of human body only. The temperature of human body normally does not go below 35 degrees Celsius or above 42 degrees Celsius. That is the reason the thermometer ranges between 35 degrees Celsius to 42 degrees Celsius. Remember, clinical thermometers cannot be used for any other purpose other than measuring body heat. That can only be done with lab thermometers. If you need to measure the temperature of boiling water, you need to use a lab thermometer. The range of a lab thermometer is between -10 degrees Celsius and 110 degrees Celsius. Now we shall learn a little about the way heat is transferred. Always remember that heat flows from higher temperatures to lower temperatures in objects. This flow of heat can happen between solids and liquids, and between liquids. It can also be between liquids and air. When heat flows between solids, it is called conduction. There are different kinds of conductors of heat among solids. Metals are generally good conductors of heat. Then again, we may also have bad conductors of heat, such as wood. These are called insulators. Heat flow in liquids is referred to as convection. Ideally, therefore, we see that heat flow requires a medium of transfer, either solid, liquid or gas. But there is also heat flow through radiation that does not require a medium. Transfer of heat from the sun to the earth takes place by the way of radiation. Here we see that the metal rod conducts heat from the fire by the way of conduction. Convection occurs when the heat waves rises up in the atmosphere and radiation is automatic passing of heat to the hands in its natural course. Remember, dark objects absorb heat better than lighter ones. So when you wear a dark colored cloth, it will absorb heat and radiate less, making you feel warm. In case of wool, it is an insulator. It does not transmit heat. Air remains trapped in between wool fibers. This air prevents the flow of heat from our body to the cold surrounding, so we feel warm. Natural radiation has many effects. In coastal areas, due to this natural source of heat energy from the sun, the land becomes hot faster than water. Sea water takes time to warm up, so cold air flows from the sea to the land. At night, the process is therefore reversed, as the water gains enough temperature during the day and stays warm at night compared to land temperature. Land is cooler at night as it starts losing heat after sunset. At night, breeze flows from the land to the sea. Let's do a quick recap on the points of what we learnt in this chapter. Temperature indicates the degree of hotness or coolness in objects. Temperature is measured in degrees Celsius or Fahrenheit. The clinical and lab thermometers are generally used to measure varying degrees of temperature. Heat flows from higher to lower temperature, causing wind movements in coastal areas during day and night. So this brings us to the end of this chapter on heat. I hope you have enjoyed the session and we look forward to meeting you in our next videos. Thanks.